When solving a quadratic equation, there are three possibilities for how many solutions there will be to the equation. There might be two solutions, there might be one solution, or there might be zero or no solutions. X squared equals 81 is an example of a quadratic equation with two solutions, meaning two values of x that make the equation true. One solution is x equals 9. 9 squared is 9 times 9, which equals 81. However, there's a second solution to this equation. The second value of x that makes this equation true is negative 9. Negative 9 squared is negative 9 times negative 9, and negative 9 times negative 9 is 81. Negative 9 and 9 are both solutions to this equation because they both make the equation true. X squared equals 0 is an example of a quadratic equation with only one solution, only one value of x that makes it true. The only value of x that I can plug into this equation and get a true statement is x equals 0. 0 squared equals 0. That is the only solution. X squared equals negative 81. Now that's an example of a quadratic equation with no solutions. There is no number that I can multiply by itself and get negative 81. To get a negative, I would need a positive times a negative, and that would not be a number squared. When I am thinking about why there could be two, one, or no solutions to a quadratic equation, I should think of the shape of a quadratic function, this parabola. So if I were trying to figure out what inputs give me an output of 81, there are two different outputs, two different points on the graph with that output. So both 9 and negative 9 give me an output of 81. However, if I'm looking for an output of 0, there's only one input. So when I'm looking at the vertex, one input gives me a particular output. And then if I'm thinking about a negative output, there are no points on this graph, no input values that give me negative 81.